Alrighty, hello. We're back with Eve's Sudoku journey. I don't know. I don't have a title for this. It's just me playing Sudoku. It's fun. Fair warning, I might sneeze or cough a little during this video, or sniffle at least, because I'm still a little sick from being sick or whatever. But I wanted to play some Sudoku because it's been a while, and I've been playing on and off, but I haven't recorded something in quite a bit. So let's do that. What I wanted to do today was actually go to a specific puzzle. So search puzzles, advanced search. I gotta say, for all the good that Logic Masters Germany brings, its search feature is just ass. It's just not very good. But I was gonna do one of the rat run puzzles. Yeah, so these have been very fun. I've solved a few of them. I have not solved many of them. This one's a 3-star. I haven't solved many 3-star puzzles in general. So let me look at 5. 5 is also a 3-star. How about 6? 6 is a 2-star. Okay. Oh, well, 6 is a 2-star, but unfortunately I've seen the crack in the cryptic video on this one. So maybe 7? If we can't find a 2-star, maybe I'll search for another puzzle. Maybe I should have done this before starting the video, huh? Or, we could just bite the bullet and try the 3-star. Okay, well, shock value is a 2-star. So, I guess, let's try that one. Before we move on to the 3 stars. So, if you don't know these puzzles, they are pretty cool. They're a series of puzzles. And basically, the goal in any of them is to draw a line. The goal, other than doing the Sudoku, is to draw a line from Finks, the rat here, to the cupcake. So Finks must get to the cupcake somehow. So that could be a path. That's probably not going to be the path, because that's very short. But, the path could also be, super long and stuff. It could go over here. In this puzzle, there's actually teleporters. So it could go into the teleporter, come out the other side, bada boom, it's something like that. So let's see. In the experiment, Finks the rat must reach cupcake by finding faster the maze. The path must not visit someone once, cross itself, or pass through any thick maze walls. As well as moving orthogonally, Finks will move diagonally if there's a 2x2 space in which to do so. So Finks may do, if the path is coming through here, Finks may do that, for example. But may never pass diagonally through a round wall spot on the corner of a cell. So the Finks can't do something like this, because that's exactly what it means by rounded corner wall, whatever that's it. I still need to buy a new mouse, by the way, so I apologize for how janky this is going to be, but that's okay. Teleports. Entering yellow teleporter will cause Finks to be instantly teleported to the other teleport. From there, she can continue her journey. The teleports contain the same digit. Interesting. So those two are the same digit. Okay. Black currents. Cells connected by black current have a 1:2 ratio. One is double the other. So these in this case. Not all possible black currents are given. And cages. They just don't repeat in a cage. Every cage has the same total, which is to be deduced. The digit on a cage's electricity symbol is its shock value. Any cage with a shock value of 5 or more is switched on, and Finks should not enter these for safety reasons. Cages with a shock value lower than 5 are switched off, and therefore safe to enter. Okay. So that's saying, all the cages have the same value. So this cage has the same value as that cage, so on and so forth. Second. But depending on the digit in the electricity symbol, so if this was 6, for example, Finks cannot go this way, so Finks would have to go that way. to escape this box. Test constraint. In this experiment, the correct path will be a valid Chinese whisper line, i.e. adjacent digits along the path must differ by at most 2. So adjacent digits, so I'm just trying to understand that because I haven't worked with Chinese whispers before, so I don't know if there's any like secrets that we should know. But for example, if that's a 1, differ by at most 2, so that could only be a 2 or a 3. Okay. If that's a 3, that could only be a 4, 5 or a 1, 2. Okay, that doesn't seem too bad. Right, let's get started then. So, first things first. The rule that really caught my eye was that every cage has to have the same total. So every cage in this puzzle has the exact same total. They just don't repeat in a cage. So, if you think about this, what's the maximum total that this cage can have? Well, it's 2 digits. The maximum they can be is 8, 9, which would make it 17. But now, what's the minimum total that this cage can have? Well, if it was the minimum digits it can be, which is 1, 2, 3, 4, 5, that would be a total of 15. So we know the cages have a total of either 15, 16, or 17. Which is interesting, because now, how can this ever be smaller than a 5? Did it say strike value of 5 or more is switched on? Yeah. So, if the cages sum to at least 16, or not 16, sorry, 15, then what's the minimum this digit could be? If this was the maximum, it could be a 9. Then if the total is 15, then this could be at least, this will have to be at least a 6. Which means this, okay, maybe I should have colors, yeah? So we're going to represent 5 or more with purple, because red I usually use for more than 5, so I use those for German whispers, for example. But here we're gonna have 2 sets of digits that are below 5, so 1, 2, 3, and 4, and we're gonna have digits above 5 or 5, which is gonna be purples. So these 2 are definitely 2 purples. Shoot, there we go. Which means Finks cannot go through this cage. Which does mean that Finks must go through this cage, because Finks must escape somehow. So, that lightning bolt is definitely blue. Maybe purple's not the best color with the red. Actually, I think it's fine, actually. Should be okay. Now, same thing can be said about this cage. It's also 2 digits, so the minimum a digit could be inside of it is 6. So they are definitely both purple. And remember, there's going to be 4 blue digits and 5 purple digits per box, per row, or per column. Now, okay, now we get to something interesting. Now, we got to think about the Chinese whisper thing, where adjacent digits in the path must differ by a value of most 2. So, what's happening with this black current here? Well, it could be 1, 2, because those differ by just 1. It could be 2, 4, because those differ by 2. But it can't be 3, 6, because those differ by 3. It can't be 4, 8, because those differ by 4. So this is either 1, 2, or 2, 4. And it definitely contains a 2 in it. Now I need to prove, somehow, that we can't enter this cage. Because if we could, the puzzle would be very simple. You could just do that to get to the cupcake. So somehow, I think we're going to have to prove that we cannot enter this cage right here. How do we do that? I know this can't be a 2. But right now, I don't see the reasoning why it couldn't be a 1, a 4, or a 3. Because yeah, we must add to at least 15, but with 4 digits to do that, it's pretty easy. Hold on, let me switch gears for a second. if the total that we're looking for is 15, then both of these cages are... Okay, here's one thing. It's not 15. The number that we're looking for is definitely not 15. And it's not 16. It's going to be 17. Because if it was 15, then these squares would have to be 1, 2, 3, 4, and 5. And these squares would have to be 1, 2, 3. 1, 2, 3. Oopsie daisy. 4 and 5. But now look at this. We have 6 digits in this box that are from 1, 2, 3, 4, and 5. And that's impossible. Now, it also can't be 16, because the only way to make 16 in 5 digits is 1, 2, 3, 4, and 6. So that's also impossible. So the total that we're looking for is definitely 17, which 1 means that this is an 8-9 pair. This is an 8-9 pair. Every cage in this puzzle adds to 17, specifically. And these two must be made in 2 different ways. Which, let me think of what the 2 different ways of making 17 in 5 digits is. One of them is 1, 2, 3, 4, 7. And the other is 1, 2, 3, 5, 6. I think those are the only 2. Let me think about that. So, let me just go through sequentially, just so I don't leave out any possibilities for being an idiot. Must it have a 1 in it? Definitely. Because if it didn't have a 1, then the minimum could be 2, 3, 4, 5, 6, which would add to 4 plus 8 plus 8 is 20. So that's impossible. So it must have a 1. It must have a 2. The minimum it would be, if it didn't, it would be 1, 3, 4, 5, and 6. Which adds to 9 plus 9 plus 1, which is 19. No. It must have a 2. Must have a 3. If it didn't, the minimum would be 1, 2, 4, 5, and 6, which adds to 10 plus 8, 18. So it must have a 3. So there we go. Each one of these cages must have a 1, a 2, and a 3. And then the other 2 digits are either 4, 7 or 5, 6. So let me draw that really quick. So 1, 2, 3. Wow, 4, 5, 6, or 7. That's not very useful. But okay, here's one thing. Well, no, hold on. How can I do this? Well, one thing that I know really quick is that 8 and 9 are contained there. They're not together. Otherwise, this square would have to be a 0. To get to 17. So that is definitely one of them. And the other is in those 2 squares. So wait a second. Both these cages have 1, 2, 3 in them. In neither case can the 1, 2, 3 be entirely contained within the single box, because then the other cage would have to have 1, 2, 3 in only 2 squares. Okay, I don't know if I can do too much with that right now, but we do have knowledge. One of these cages is 1, 2, 3, 4, 7. The other is 1, 2, 3, 5, 6. Okay. I think that's all we know of those cages so far, unfortunately. Now, there are a few interesting things happening path-wise, actually. Because if we don't go left here, which I still think we're not going to go left, I just need to figure out why. I'll do that in a second. If we go left, if we don't go left, we're going to go right. And then we're going to have to either enter the teleporter, which is going to spit us out there, or we're going to have to exit through this wall here, because that's the only way of getting from this side of the maze to this side of the maze. And then if we exit that wall, that square needs to be below 5, which is interesting. I'm not exactly sure what that means quite yet. But we'll figure it out. One thing that I can think of really quick... No, not really. I was trying to think of where 8 and 9 could go in this box. I can't really figure it out. They can't go there, obviously, because 8 and 9 are over there, but they're going somewhere in here. Well, they're not going there, actually, because those are in the thingies. Okay. Yeah, I don't know, actually. Shit. Well, one thing we know, first, is that these are blue, definitely. These are from 1, 2, and 4. Now, this is from 1, 2, 3, and 4, because it's also blue. We know that much, because Sphinx goes through it. What does that mean? What does this relation mean? If this is a 1, 2 pair, that could be anything, really. Okay. I feel like I'm a bit lost, to be honest with you. But we'll get there. Maybe I shouldn't color all digits. Maybe I should just color... Actually, no, all digits is good, because then I'll figure out whatever's missing. Yeah. One thing that I could say really quick is that this is definitely a 2 or 4. Because it's in the middle of 2 black Kropki dots. So one thing that it can't be is a 3 or a 6. Because if it was a 3, both of these would have to be 6. If it was a 6, both of these would have to be 3. So it has to be from the sequence 1, 2, 4, and 8. It can't be a 1, because both of these would have to be 2s. It can't be an 8, because both of these would have to be 4s. So it's definitely a 2 or a 4. Which makes it blue. Now, what does that mean? I don't know. I am quite stumped here at the moment. Okay, how do we prove that this can't be a safe box? I don't know. 17 and 5 digits, or 4 digits, is really not that hard to do. Could be something like 1, 2, 3, 8. 1, 2, 3, 9 would work. Obviously, in this case, it can't be 1, 2, 3, 9 because 2 is over there, but you know what I mean. Well, I guess in that case, one little thing we can say is that 9 is not in this box. 9's not here because that. So 9 is down there. Which is interesting, because it puts 9 up here. 9 is definitely not there, because 9 can't go in a black Kropki dot, so 9 is there. So we get a digit out of nowhere. That's good. That's always nice, you know? One second. Sorry. Oh, man. I really think we need to think about these boxes somehow, but I don't know how. Quite yet. Well, okay, one interesting thing. This black Kropki dot doesn't have a 2 in it. It doesn't have an 8. So it can't be 1, 2, 2, 4, or 4, 8. So it's definitely a 3, 6 pair. Which is something, I guess. That is something, for sure. Oh, okay, one interesting thing I just realized. If Sphinx goes through the teleporter, she's gonna come out through here, but then she can't come in through this wall because that cage is unsafe. So she would have to come in through here, which would make that square small. Now, I can assure you 100% that Sphinx will go through the teleporter because the teleporter is part of the puzzle. And Marty would not have put a teleporter in the puzzle if the teleporter was not used. However, I can't just assume that, so I can't say for certain that Finks will go through the teleporter, but I'm gonna say Finks will go through the teleporter. Alright? Just you wait. Just you wait. You're gonna see it. It's gonna be great. Okay, you're gonna love it. Everyone always loves when Finks goes through the teleporter. I'm gonna tell you. It's the best time. This is amazing. One thing, this can't be a 1. Because if this was a 1, these have to add to 16, which would be 7, 9, but 9's already taken, so this can't be a 1. If this was a 2, these have to add to 15, which would either be 6, 9, or 7, 8. 8 and 9 are already taken, so this can't be a 2. If this was a 3, this would have to add to 14, which is either 5, 9, or 6, 8. Those are already taken, so this is a 4. There we go, we did something. What a concept. So now these have to add to 13, which can be done as 6, 7. There we go. And now these are high digits. Okay. Made a little bit of progress. That's good. That's always good. So this is a 1 or 2 now. This is a 1, 2, or 4 still. Yeah. Which actually, yeah, that's interesting. Because that means any 3 cages, they don't have too many ways of having a low digit in their lightning bolt. What are the options here? 1, 2, 3, 4, 7, and 1, 2, 3, 5, 6. Okay. Alright, where am I supposed to look? It's a great question. I do not know at the moment. I know those two are the same digit. That's not extremely useful at the moment. I imagine it will be someday. Chinese Whisper. This can't be a 7, because it must differ at most 2, so this is a 6. That's a 7. And now this must differ at most 2. It's not a 9, it's not an 8, it's not a 6, so it is a 5. There we go. Sorry, that is large. So actually, these are all small. They are 1, 2, and 3. That's definitely not a 3. That is a 1 or a 2. Going together with a 2 or a 4 means that's either a 4 or 2, 4, 8. Yeah. But it can't be a 4. Because we already have, we already have 4 small digits in this row. So these are all big. There we go. We proved that this is big. So the cage is unsafe, and now Finks must travel this away. And, cool thing, now we proved that this is large, and the only large digit in the sequence 1, 2, 4, 8 is 8. And that is a 4. And that is a 2. These are not 2s. Okay, I'm starting to see why this is a 2-star puzzle now. It's actually not too bad. Now, which way must Finks go? She can't go here, because that differs by 4. So she must go down. And now this digit must differ by 2 at most from 4. So it's either a 2, a 3, a 5, or a 6. It's not a 5. But now, Finks must definitely... Well, she can go... Whoops. She could go like this, if this was a 6. Or she can go like this. Okay, here's one thing. This can't be 2 or 3. Because if this was 2 or 3, Finks has to escape, right? This box. So she definitely has to go this way at some point. So she must come from somewhere into this 8. She must come from a 6, a 7, or a 9. She can't come from a 9, because 9's already there. So if this wasn't 2 or 3, then this would have to be 6 or 7. But now, Finks can't go over here, because even if this was 3, going to a 6 would be a jump of 3. So this is definitely a 6. And Finks travels diagonally into the 8. And this is not 6 or 7, I was just using that for an example. But yeah, there we go. Cool. And now this must differ by at most 2. It can't be an 8, so it's a 7. Very cool. This must differ by at most 2. It can't be an 8 or a 9, so it can't be a 6 either, so it is a 5. And now all high digits are taken in this box, so these are all low. This is actually really cool. I really like this so far. 1, 2, and 3 go in those. And now we must make choices. Which one of these cages is Sphinx gonna be able to go through? Place your bets now. I do not know, but I do know that this is large. And I think I broke the puzzle. No, I didn't, because I forgot that 5 is a large digit. This is at most a 3. The biggest digit that can go together with a 3 is a 5. And 5 is the smallest large digit, so that is a 5, definitely. Now, this can't be a 2, because that would be a difference of 3. It can't be a 1, because that would be a difference of 4. So that's a 4, that's a 2 to make that black crocky dot work. These are 6 and 7, because that's what's left in that row. And now, what? Now, if Sphinx goes left, that must be a 3. If Sphinx goes down, that has to not only be small to make that cage safe, but it must also be okay with this 5 by Chinese Whisper. So it'd have to be a 3 or a 4. Now, if it's a 3, that's a 6. Oh, okay, there we go. It can't go... Oh, wait. No, it could still go down. Okay. If it goes down, then it must happen in a very specific way. So if Sphinx goes down, she goes all the way down. She can't turn back around. And then, what is this black crocky dot? Well, this has to be a 3 or 4, like we said, because it has to be small to make this cage safe. And it has to be at most 2 away from a 5. If this was a 3, that would be a 6. That breaks the Chinese Whisper, because 3, 6 is 3 away. So that's not a 3, that would be a 4. Now 4 can't go together with an 8, because that would be 4 away. So 4 would have to go together with a 2. And now this would have to be a 1 or 3. Which I think breaks the cage, adding up to 17. Because if this is 1, 2, 4, that's 7. This now can't add to 17, that would have to be a 10. If this is 2, 3, 4, that's 9. This can add to 17 if that's an 8, but that breaks the Chinese Whisper, because this would be a 3, 8. So, we've disproven, we've proven that Sphinx cannot go down. So Sphinx must go left, which means that is a 3. Now, we don't know if Sphinx goes left again, or if she now goes down. I don't know how we can prove that, but we'll get there in a second. Just to finish off a few things. These are both small. They are 1 and 3. And indeed, 1, 3, 6, 7 adds to 17. So, got that covered. These are both large, and they are 8 and 9. Very cool. Okay, now what? Now I think we're gonna have to think about this cage. Oh, well, one thing we can do really quick is we can find this digit, because here's a little secret. Each box, each row, and each column of a Sudoku, when completed, will add to 45, because that is the digits 1 through 9 added up. But we know these two cages add to 17, so those two together add to 34. So what must these add to? They must add to 11. Because it must get to 45. But if those add to 11, this whole cage needs to add 17, so that must be 6. Very cool. I'm sorry that I still do that. I'm dumb. I really shouldn't do that, but yeah. Which, actually, that's 6 gets us that's a 3 and that's a 6 out of nowhere. That doesn't tell us how these cages work, because like I said, both of these cages have 1, 2, and 3, and then one is 4, 7, one's 5, 6. But progress. Oh wait, actually that does tell us, because now this can't be 1, 2, 3, 4, 7, because 4 can't go anywhere in these. So this cage is 1, 2, 3, 4, 7, in this cage is 1, 2, 3. 3's already done. 5 and 6. Those are not 6s. That's not a 3. It's not a 7. Excuse me. It's not a 7. Because 7 can't go on a black croppy dot. Neither here. This is not a 3, because this can't be a 6. So 2 is definitely in this croppy dot. It's either 1, 2, or 2, 4. So 2 is nowhere else in this cage. That's not a 7 either. And now... what? What is my next trick? I don't know. Not sure. I think a trick that's going to happen soon is proving that that's large, so that we block off this case, so that Finks must go through the teleporter. But I can't prove that quite yet. One thing I can do really quick is this is a 6, so these must add to 11. But these add to a multiple of 3. And the way I know that is that one of these is double the other. So, one of these digits is going to be a digit called x, and the other is going to be 2x. So them added together is going to be 3x. So they are either 3, 6, or 9. They can't be 12, because, these add to 11, so that would have to be minus 1. So if they add to 3, that is an 8. If they add to 6, that is a 5, which it can't be. And if they add to 9, that is a 2. So that's either a 2 or an 8. If that's an 8, these are... oh, it can't add to 9, actually, because for them to add to 9, these have to be 3, 6, but neither of these can be 6. So they definitely add to 3. So they are a 1, 2 pair. They're both small, which makes that an 8. And they is large. Very cool. Now, okay, now that's actually good, because now that makes it hard for either of these to be, oh, that's a 9, that's an 8. It makes it hard for either of these to be small, because they can't be 1 or 2, so they would have to be 3 or 4. If this was small, it would be forced to be a 4, because it can't be a 3. If this is small, it would be forced to be a 3, because it can't be a 4. But one of these has to be small, because Finks must continue her path somehow. Which is interesting, isn't it? How is that gonna work? They must add to 17. So if that's small, that's 4. And now these must add to 17. So they can't be 4, 9, because 4 is already taken. They would be 5, 8, which they can't be. Or they would add 17. They would add to 13, sorry. To complete the 17. They would have to be 5, 8, which they can't be, or 6, 7. In which case, this would have to be a 6. Because of the Chinese whisper, and that would have to be 7. That is possible. That is very possible. So if this is the path Finks takes, it is 4, 6, 7. Definitely. Now, if this is the path Finks takes, that would be forced to be a 3, which is actually okay for Chinese whisper from a 1. But then, these have to add to 14. They could be 5, 9. They can't. They can't be 5, 9, because then this would be forced to be 9. 3 and 9 are not 2 apart, or less. And they can't be 6, 8. So there we go. Finks can't go down this path, because it would be 3, followed by something that doesn't allow itself, because of the Chinese whispers. So Finks goes down this path, and indeed we have this situation, 4, 6, 7. Bam. Bam, bam. Now, we can mark these really quick. These are 3 and 4, which means that is a 3 or 4, because of how the teleporter works. Even if Finks doesn't take the teleporter, which, again, she will, those are definitely the same digit, by rules. That is right? Even if she doesn't take the teleporter? Teleporters contain the same digit. Yeah, no matter what. Okay. These are 1, 5 and 9. 5 and 9 can't go on a blackcurrant, so that is a 1, which makes that a 2. Which makes this not a 1 or 2. That's not a 1. These aren't 1s. Both of those are okay for Chinese Whisper, actually. We can mark these really quick. These are 3, 5, and 9. That can't be a 9. These are 7 and 8. So they're definitely large. These are definitely large as well. Okay, now I think we can prove that this is impossible. Yeah, okay. Because now this can't be small. Because if it was small, it would be 3 or 4. Because it can't be a 1 or 2. But if it's 2, 3, that's 5. That would have to be a 12 to add to 17. If it's 2, 4, that's 6. That would have to be an 11. So that is definitely large, which now makes this path impossible, which now means, lo and behold, Figs goes through a teleporter. Told you it was going to happen. Alright? Told you it was going to happen. She'll must definitely go through there. I don't know if she snakes around a little. I guess that's possible still. Actually, it's going to happen, because she can't go straight. Because that would be jumping from a 9 to a 5, or a 5 to a 9, which is too bad. Now, I don't know if she sneaks around like this, or like this, or like, oh shit. Like that, or like this. I think those are all possible right now, which is weird. Shit, 1 second. What the? I'm getting a call to action, which unfortunately I can't answer right now. This must also be large, because it's the same rule that we applied to this. Okay. These must add to 15, so they must either be a 6-9 pair, or a 7-8 pair. They can't be 7, because that's 7 there, so this is a 6-9 pair. And we know the order. Which now, this ambiguates all of this. Which is good, because now, this and this are disallowed, because 8 and 5 can't go together on the Chinese Whisper, so this must happen. And now what? Now that's a 5. Those aren't 5s. That's a 1-2 pair, which makes that a 6. These are both large. These are both small. They're a 1-2 pair, so that's a 4, making that a 2. Making those not 4s. That's not a 4 because the cage. 1-2 pair means that's not a 1. 3-7 pair on the cage makes that a 1. Sorry, I'm like having to answer a call at the same time as I'm doing this. There's a 3 or 4 by just Sudoku. Oh, it's actually a 3. There we go. So that's definitely small, which is good because that works for the Chinese Whisper. These by Sudoku are... Actually, I can't tell. Oh, 3 and 7 makes that a 1. Makes that a 3. Which now makes these 8, 9, or... This is definitely not an 8 or 9 because it's Chinese Whisper. Thankfully, the other option is a 5. So there we go. That's a 5. This is a 9, 8, 9, 9. That is a 9. So it's like that. These are big. They are 7 and 8. 7, 8. Okay, now, how must Sphinx continue? She can't go down because that's the difference of 5. She can't go left because that's the difference of 3. She must go like that. Unfortunately, now I'm not sure how she's going to continue, but we'll see. Oh, Sphinx can go in this cage, by the way, because that is small. Which is good, because she must go through this cage, because as I said, she can't go through here, because that cage is big, so that cage is blocked off. So Sphinx is definitely going to go... Yeah, she can never enter that cage, actually. So she's definitely going to go down from here. Because if she went anywhere else, she'd be stuck having to enter that cage. So she goes down. Now she can't go right or down, because that's bad for the Chinese Whisper, so she's going to do that. And now, for my next trick, I'm not sure. Now I'm not sure how she's gonna get out of this one, but we'll figure that out in a second. Meanwhile, in Sudoku land, this is a 1, 2, or 5. One of these cages is definitely gonna have to be safe for things to get to the cupcake. Don't know which. That, well, these two by Sudoku are 1. Well, there we go. That's a 1, and that is a 7. Which makes that a 3, that a 7, which gives us a bit more info about the path, actually. This is a 4. Actually, I knew that was a 4 already because it's a teleporter, but whatever. 2, 1. Okay. Yeah, so now, Sphinx can't go down because that would be a difference of 3. She can... She doesn't have the option of going to either of these, because one of these is going to be a 1. But I don't know which one. Oh, but, yeah. If she goes here, then that means that's a 2. That's not the 1. But now where does she go? Well, actually, she should go up to the 1. Dumb question. My bad. Well, it's not actually an extremely dumb question. Because that does give us something. It doesn't give us... Actually, okay. Here's one thing. Sphinx can't go through here. So Sphinx can't go out through this box. Through this, door here. Because that's a difference of 3 on that path. So Sphinx must go out through here. That's the only other way of escaping this box. Otherwise she would escape through here and she would have to bump into her own path. So somehow, Sphinx must get to that 5. Now, she can't get to that 5 from this 2. If that's a 2. Or if that's a 1. Either way, she can't get to that from that. She could get to that 5 from the 7. Or from the 3. But the problem is, how do you get to the 7 from the 4? You'd have to go through either a 5 or 6. And the 5 or 6 is all the way down here. So that's impossible. So she must get through there, through the 3. But now she needs to get to the 3, and the only way of getting to the 3 is through this square. And for that to work, that actually doesn't solve if that's a 1 or a 2, because that could be the case with that being a 2, or that could be the case with that being a 2 and that being a 1. So I'm actually not sure which one it is. Either way, this path is going to connect there at some point. Oh. That's my hormones. These are 6 and 7, by the way. So they are large. I'll be back in just a second. I'm sorry. Great news. I will not be back in a second because my hormones are right here, actually. I thought I left them in the other room. I did not. It's actually not very easy for that cage on the right to be... Oh, fuck. You know what I did leave in the other room? Water. I will be right back. My bad. Oh, jeez. Sorry, I almost made a gigantic water spill all over my computer. That would have been bad. Hopefully that did not happen. These are 2, 3, and 5. Yeah, that's what I was saying. It's not very easy for this cage to be unsafe now, because it would have to be exactly a 5. Well, actually, same thing with this one, I guess. Huh. Okay. How is this gonna happen? Do not know. Things could go up. Actually, we can fill out these. These are 8 and 9. Which actually doesn't help at all. Because I was gonna say, things could go up, because that is definitely fine for Chinese Whisper. Or, now, things could go this way, because that is fine for Chinese Whisper as well. Well, it's fine, but then what is this square? The square is 1, 2, or 4. And that's definitely not close enough to either option of 8 and 9. So things does not go that way. She goes this way. And now, look at this. This is also 1, 2, or 4. And the only one that's close enough to 6 is a 4. So now that's a 1 or 2. This is definitely small. These are definitely large. That is definitely small. And we're almost done. I'll just have like 1 or 2 more bits of logic to figure out here. But how? Oh, the cage totals, I think. I haven't thought about the cage totals in a while. That probably will solve this, isn't it? Whichever one of these is unsafe, which one of them must be, because there must be a 5 in this box. There must be a 5 in this box. Actually, hold on. Well, no, actually. It's still theoretically possible that neither of these cages is unsafe. Which I don't think is going to be the case, because then the puzzle would probably have 2 solutions, but... Well, maybe not, because of Chinese Whisper. Hold on. Okay. Better question. One of these cages has a 7 in them. Yeah, there we go. Okay. That's what I should have been asking the whole time. Never mind, actually. That's a bad question. What is the better question I should be asking? I don't know. Hold on. I'm lost. I'm thinking the last bit of logic here is thinking about the cage totals. But I don't know how to think about them quite yet. One thing I just realized, actually, is that I have a 6-9, a 6-7 pair on both of these columns, and an 8-9 pair on both these columns. So these cages are only from, well, these squares actually are only from the digits 1 through 5. Which that is interesting, actually, because now, yeah, that is a little more interesting, because now, what's going to happen? One of these cages is going to have a 7 in them, and then the other 3 digits must add to 10. But the only way of adding to 10 in 3 digits without the digits 9, 8, 7, or 6, I think, is it's 5. It's 2, 3, 5. So one of these cages is a 7, 2, 3, 5 cage, and the other is a 6, and the 3 other digits add to 11. So they're gonna be, but they can use a 7. So it could be 7, 1, 3, for example. That would be fine. Oh wait, shit. The cage with the 7 can actually use a 6. I forgot about that. It could use a 6. Well, no, it can't use a 6. Oh, it can't use a 6. Okay. Never mind. Neither of these cages. Well, neither of these bits of these cages can use the digits 6, 7, 8, or 9. Because of the columns. Right, I forgot about that. My brain did a dummy there for a second. My bad. So the deduction I did was correct. One of these is going to be 7, 2, 3, 5. The other is going to be 6, and the digits are going to add to 11. Now, how are they going to do that? Great question. They don't have a 1, because then the other 2 digits would have to add to... Actually, they could have a 1. It could be 1, 4, 5. Well, 1, 4, 5 adds to 10. Well, shit. No, they can't have a 1. There we go, yeah. They can't have a 1, because the other 2 digits would have to add to 10, and that would require one of the digits above 5, which we can't use any of those. Which actually, I think that means, yeah, one of these cages is going to have a 6, and it can't have a 1. The other is going to have a 7, and the other 2 digits, and the other 3 digits are 2, 3, 5. So neither of these cages can have a 1. Neither of these is 1. That is a 1. That's a 2. That's a 1. That's a 3, 1. That's not a 3 now. And now, this cage can't be 2, 3, 5. So this is the 2, 3, 5 cage. That is a 7. That is a 6. 7, 6. This is from 2, 3, and 5. It's actually not a 2. And now this is a 2, 5 pair, so we know what this is. This is a 2, 5 pair. It adds to 7. Plus 6 is 13. To get to 17, that is a 4. Okay. Now we're extremely close. But we still have not proven which one of these cages is the safe one. How the heck have we not done that yet? I do not know. Okay, here's one thing. 4 can't go to a 1. So 4 is going to have to go either up here or here. Now, if it goes up here, that must be a 2. Because if that was a 5, this cage would be unsafe and that connection would be impossible. If it goes up here, it could be either 1, but that is definitely a 2 or a 3. Definitely. I'm confused. Like I'm losing my mind. I mean, everything is okay so far. Yeah, no, I'm extremely close to finishing it. I just don't know how. Is it this cage that's gonna do it somehow? Whoops. Also, I still don't know how to do this part. Actually, yes, I do. Because now I can't go like this. So actually, it does connect like that. My bad. Lots of diagonal connections in this one. Normally, you don't have that many in these rat run puzzles. This one has a bunch. It's actually pretty cool. I like that. This would actually work really well. This path, because that would be a 2, which is okay for Chinese Whisper. Then 4, which is okay. 5, 6, 8, and 9. Those are all okay for Chinese Whisper. What about this one? Oh, there we go. Cool. Yeah. This, the path can't go through this cage, because that's a 7. So, if the path went to this cage by Chinese Whisper, that would have to be a 5. But if that's a 5, the cage is unsafe. There we go. Cool. So the path does go through this cage, and right into the cupcake, which means the connection is that one, which means, ladies and gentlemen, that is a 2, 5, 5, 3, 2, 3, 5. And now we're extremely close to being done. And in fact, we're done, because that can't be a 9 by Chinese Whisper. 8, 9, 8, 9. What a puzzle. Holy crap, that was really cool. That was actually really, really cool. I really enjoyed that one. These rat run puzzles are always, like, a joy to play. But that was really, really interesting. Just all the mechanics working together, like every second of the puzzle was super interesting. I like that you could figure out a lot of the ideas of how the puzzle worked very, very quickly. Like me figuring out that the cage added 17. That happened really early. But then actually using that was super interesting. I really, really enjoyed that. It was really, really, really cool. My concerns about the ethics of this experiment were perhaps a little unwarranted. Finks remained as focused and determined as ever. If anything, she appeared to relish the challenge of determining which cages were safe to enter. I now feel much more at ease about how she'll cope with next week's sensory deprivation experiment. Marty, what are you doing to this poor rat? Is 10 out yet? It's not. It's gonna come out, like, in 2 days. Finks, I am so sorry. You deserve much better than this. Maybe next time we'll try one of the 3-star puzzles, because that was really, really cool. I really like these line drawing puzzles, and the rat run ones they're always interesting. They're always super interesting. That's a really cool path, too, for that. It's all around the board. That's super cool. That's super, super cool. I really like that. Marty, that was amazing. That was really, really cool. Really, really enjoyed it. There we go. Well, I mean, this video is an hour long already, so we're definitely not going to do another puzzle. But I don't think we need to. That puzzle's just immaculate. I really, really liked it. Anyway, yeah, that's it. Good night.